All right, so this is one of my very favorite topics in Algebra 2, and it has to do with systems. And what we're going to do, what we're going to do when we're talking about systems is instead of doing two variables like you did in Algebra 1, we're going to work with three different variables. So if you remember in Algebra 1, whenever we were looking at systems of two variables, we were just like finding the intersection of lines, right? Because you had an x-plane and a y-plane. But when we're talking about three variables, we have a three-dimensional plane. So instead of talking about intersections of lines, you can see examples are intersections of planes. So a couple different things can happen. It could intersect at one single point right here, which is the ones that we like. Those are called consistent, right? Because they have one single point where they all meet. Now, this is also called consistent, but there's infinitely many points. So you can see that these three planes actually touch each other in a line, right? So there's infinitely many places where they intersect, but it's in a line. You can have an inconsistent system of three variables, and that's when there is no single spot that all three planes touch, which means they could not touch at all, which means that they could touch one but not another, something like this. So these are the kind of situations that we're going to run into. The first is the most likely. So how do we do this? We reviewed systems of two variables, so let's see how that might help us with systems of three variables. First thing I do, I'm going to zoom in on this one. The first thing I do is I actually number my equations. It makes it easier for me. So I'm going to call this, or I guess I letter them, A, B, and C. And I'm going to look for a variable that's super easy to eliminate. Now, if you notice, A and B, one has a positive y and one has a negative y. So if I add these together, the y's will get eliminated. So here's what I'm going to do. I'm going to add equation 1, or sorry, I called them A and B. Whoops. I'm going to add A plus B. And let's see what happens. 2x minus y plus 3z equals -1. And x plus y minus z equals 0. And this is -1. Go ahead and add vertically. I end up with 3x. My y's get eliminated, right? And then I end up with positive 2z equals -1. So now I'm going to call this equation D, okay? Now, I eliminated y. I need to eliminate y one more time in order to have another equation of just x and z. So let's eliminate y again. Here's what I'm going to do. I'm going to take 3 times my equation A, because then I'll have a -3y in there, right? And that will eliminate with a positive 3y in C. So I'm going to triple every single thing in my first equation. And I'm going to leave, I shouldn't have written that line. I'm going to leave this C equation the same. I'm going to add. I should get 9x. My y's eliminate. 7z equals -2. We're going to call this E. Now look, if you do this right, the two equations that you make will have the same variables in them because you have to eliminate the same variable twice. So now we're going to use equation D and equation E, and what I notice is that if I have a 3 here and a 9 here, if I force this to be -9, it'll cancel it out. So let's take -3 times my D equation. It'll be -9x, -6z, and 3. And let's add it to my E equation. I'm going to get 9x plus 7z equals -2. Look how nicely this works out. These get eliminated. This will be just z, and this will be 1. So look, z equals 1. So this is the easy part. Now I can just plug in z equals 1 to any of the D or the E. So let's see, 9x plus 7 equals -2. 9x equals -9. So x equals -1. And now I have 2 of 3 variables. So pick any of the originals to go ahead and plug x and z into. Let's just plug it into B. So b is going to be -1 plus y minus z, which is 1, equals 0. We get y equals 2. So now, the way we write this is we write x, comma, y, comma, z. So in our case, -1, 2, 1. And this will work for all three equations. That is one consistent answer. Now let's try another one. Let's try this one. When I first see this, I'm thinking, okay, we're going to call this A, B, and C. What variable will be really easy to eliminate? So you kind of have to look at it. And I think I want to eliminate X because I see like 6 and 3s. So if we add B and C, if we add them, and I'm just going to do that right here, I end up with -3y minus 9z equals -51. We're going to call that D. So we eliminated X. So maybe write a note to yourself. This is what I'm eliminating first. And then I could take A, right? -6x plus y minus z equals -23. And if I double B, I'll have positive 6x. -6d. Okay. So when I do this, my x's will cancel out again. I'm going to get -11y minus 7z. That looks really hard to read. So let's see, -11y minus 7z equals -83. Okay, this is my E. So now I have D and E. Now the easiest way to get rid of it is that I need to find either numbers that 11 and 3 go into or 7 and 9. And honestly, it doesn't really matter. I'm going to actually go ahead and say 11 times D, and I'm going to do -3 times E. That's going to force this to be 33y, or I guess -33y, and this will be positive 33y. So let's go ahead and multiply everything. 11 times all of D will be -33y minus 99z equals -561. And if I take -3 times all of E, I will get 33y plus 21z equals 249. Those will go away. We'll get -78z equals -312. And we get z equals 4. Okay? Once we get 1, we kind of work our way backwards. Plug in z equals 4 to either D or E. And I think I plugged it into D, I think, when I was doing this. So let's plug z equals 4 into D. We would get -3y minus, let's see, 9 times 4 is what, 36? Equals -51. -3y equals -15. So y equals 5. And then when you plug that back into any of the originals, I think I plugged it into A, I think. So when I plugged that into A, I got -6x, let's see, plus 5 minus 4 equals -23. Let's see, 124. I think I ended up with x equals 4. And the way we write our final answer is x, y, z. So 4, 5, 4. And that's our ordered triple, as we like to call it. So these are long, but the key ideas is to decide a variable to eliminate twice, and then use those two, D and E, to eliminate again. And then you kind of work your way backwards. So I'm going to pause. You try number 3. See if you are able to get, let's see, my final answer was -213. See if you can do that on your own. And if you can't get that, that's a good